Okay, so today we're going to talk about the logarithmic function. And hopefully you've had a bit of a chance to try the investigation from yesterday's work to just get a sense of what the logarithmic function is. The connection that you would have made in that investigation yesterday was that the logarithmic function is the inverse of the exponential function. And you'll see those connections as we go through things today and tomorrow. So, the formal definition, though, that you're copying down right now says the logarithm of a number to a base is the exponent to which that base must be raised to get that number. So if I was doing a quadratic formula or a function, you take some number and you square it and you get an answer. So you're asking yourself, you put in a 5, what do you get? In an answer, 5 squared is 25. The exponential function, you have something like 2 to the power of x. So you put in some number like 5, and you say, okay, what's 2 to the power of 5? A logarithm is a similar function, except now the question you're asking is, what number do I put on some base? What exponent do I put on some base to get a given number? So it's best to see what I mean in an example. They look a little bit differently, but here's an example. So the way we read this is in green there, log 8 base 2. So we say log 8, and then we ask ourselves what the base of 2 is. So what we are asking when I ask for the logarithm of 8 base 2 is I am asking what exponent do we need on base 2 to get 8? What exponent do I put on a 2 to get an 8? And today, we're pretty much just asking that question and helping get used to the terminology and the language and everything like that. So it doesn't take much stretch. You start asking yourself, what exponent do I put on at base 2 to get 8? So you think, well, is it 2? 2 squared is 4. No. Is it 4? Oh, 2 to the power of 4 is 16. That's too big. So is it 3? 2 to the power of 3 is 8. And so I know that log 8 base 2 is 3. B/C here means because. So I know that log 8 base 2 is 3 because 2 to the power of 3 is 8. What's important to remember is that logs are exponents. It's highlighted in the definition there. Logarithms are exponents. That's a very important thing to remember. I'm going to say it lots and lots and lots and lots in this unit, because the rules that apply for exponents also apply for logarithms. They just look a little bit differently. Okay, so let's run through a couple examples. So in example 2 here, I've just asked you to evaluate the logarithm. Okay, so in the first one, this says log 100 base 10. So I want you to ask yourself, what exponent do I put on 10 to get 100? And hopefully we all know that the exponent you put on 10 to get 100 is 2. And over here, this is just my own thought process. You're not going to need to write this down every single time. But the reason is because 10 to the power of 2 is 100. That's why I'm just checking to see if it makes sense. Let's try another one. Again, I'd like you to try and say this on your own, but it's pronounced log 9 base 3. And it means, what exponent do I put on 3 to get 9? And again, you should be able to see that it's 2 because 3 squared is 9. Somebody can try and read this. Good. Well, hopefully you said this is log 125 base 2 or base 5, which means what exponent do you put on 5 to get 125? And it's 3 because 5 to the power 3 is 125. So it's just getting used to the language, being able to say it and communicate it, and also just thinking about what the actual answer is when I ask you to find a logarithm. Now, special note, the relation log 100 base 10 equals 2 is a logarithmic equation. And it can be written as an exponential equation. There's a big connection between logarithms and logarithmic functions and exponential functions. So naturally, there's a balance between logarithmic equations and exponential equations. What you'll see here is this is the logarithmic equation, and this is the corresponding exponential equations. Because we have experience in dealing with exponential equations, often we'll be converting from logarithmic to exponential. So that's what example 3 asks us to do. Express the logarithmic equation in an exponential equation. So I'm not evaluating here, I know what the answer is, but I want you to rewrite it and get comfortable in writing it in one form or the other. Because depending on the question, you'll want to leave it as logarithms and answer it as a logarithmic equation, or convert it to exponentials and solve that way. So this one I'd like you to express as an exponential. Well, this says log 10,000 base 10 equals 4. So just by me saying that, I know that it's base 10. So it's going to be the 10 here to some exponent. Remember, logs are exponents. So the exponent is 4. And it equals an answer of 10,000. Try another one. Log 49 base 7 equals 2. So this asks, what exponent do you put on 7 to get 49? Well, the answer is 2. So the exponent is 2 that you put on 7. So if the base is 7, the exponent is 2, you get a 49. In general, we have it like this. So there's the logarithmic equation on the left-hand side in general terms, and the corresponding exponential equation on the right-hand side. Let's label the parts. Remember, logs have bases in them, so that's an easy one. There's the base A. In the exponential, there's the base of the exponent. Logs are exponents, so the log is an exponent, so in this case, the y is the exponent. And obviously, we can see the exponent here. And then this number here, the weird one here, doesn't really have a name. So what I just call it, I call it the answer. You could call it the answer, but I like to call it the answer because I'm not really sure what it's called, so it's just called the answer. Please don't go to university next year and use that because you'll look like a fool. But I have no problem looking like a fool. So knowing all the parts, we have log of x base a, so there's the base, equals the exponent of y, because it asks what exponent do I put on a to get x, to get the answer of x. Here it is in exponential form, a to the y equals the answer of x.